Hello there, it's Jay here from Jay's Vintage Junk. And if you haven't guessed already, yeah, we're back on with the Amstrad PC2286 PSU, the one that basically had horrendous capacitor leakage on it. You saw in the previous video on this computer. And I've actually spent a fair bit of time carrying on cleaning up, basically with PCB cleaner, Q-tips, cotton towel, you name it. I've basically been trying to clean up this as much as I can. The trouble is, this electrolyte has gone literally everywhere. It's underneath this heatsink. I think it's probably underneath the switching transformer there. It's certainly underneath these capacitors here and in all these leads here. I think what I'm going to have to do is basically pretty much strip down most of this part. It's all over here as well. I've got rid of a lot of it, but if I take the soldering iron, this is a good test really, and I just sweep it along the board here, and I have a smell like that. I can still smell that bad fish smell, so it's still on the board. I might even go to the point of, once I've taken things off like these transformers and all the major components, I might even take the board and wash it in the sink and then dry it off, and then we can start repopulating. It might be the best way to go with this actually. It really is that that disgusting. I have ordered some new 68,000 UF 16 volt capacitors. Unfortunately, price wise, and I had to go with what I could afford. They are coming from China, so there will be a little bit of a time getting here. But what I thought we could do, once we've done all the clean-up work and we're actually ready to apply power to this and see how far we get, I've got some caps I've pulled off some scrap boards. We haven't got 68,000 UF capacitors, but what I have got is I've got a couple of 47s there at 25 volts, and I've got a couple of 2200s there at 25 volts. Now, if we parallel that, we might actually just get away with putting the 47s in. I know it's not right, but it should work. It should just probably not quite be right. It should prove that the power supply basically works, but if it won't work with them, we could always parallel those up as well. Would be a bit higher than the 68,000 that it should be, but it should be good enough for testing and good enough for proving that, like, the rest of the supply is actually good. We should be able to get some voltage output from it, and then when the correct capacitors arrive, I think Lou was saying they should be here about November the 8th, I think. Sorry, quick slurp of coffee. So, like I said, when those arrive, we can actually put them in the board, and all being well, that is, that we can actually get this board to work. If not, like I said, it's a nice big board, it's a nice big case. I'm pretty sure we can take another power supply, either another AT power supply or even perhaps an ATX one, or something that I've got that will have the correct voltages we need on it anyway. And put it in this case, and perhaps cut that bit of the board off so we've still got the switch and the wiring and there's things we can do. But actually I would really like to get this power supply working and keep it all original, because I know a lot of people diss Amstrad, and there are many issues with certain Amstrad products. This power supply is actually, from what I can see, and I will tell you, I am not an expert on switch mode power supplies. In fact, one of the things I least like working on of any form of electronics is switch mode power supplies. Especially the newer ones in like LCD TVs and stuff. They send a cold shiver down my spine, because I did have to repair a lot of them at one point for a company I worked for, and horrible things. The problem with them is they have what you can really refer to as cascade failure, as in one component fails and it sends basically a cascade of failure through the rest of the power supply. And the trouble is, unless you get every single part there that's failed and actually fix that fault. You can change most of them parts, switch it on, power it back up, and the cascade happens again, and you blow all the components you've just replaced. They are a pigging nightmare to work on. That being said, this is older, this is more simple, this is more basic as switch mode power supplies go. I do kind of sort of understand how this kind of switch mode power supply works. The thing that does scare me slightly is that thing there, which is kind of like a custom control module. Quick lesson from someone who is not an expert on how basically a switch mode power supply works. You've got your mains coming in here. You've got basically rectification to convert that mains to DC. Smooth DC through that. So you end up with perhaps about 400 volts ish of DC directly off the mains, basically smooth and rectified DC off the mains at about 400-ish volts. That is basically put into a switching transformer via a very high speed switching controller. It's usually on the really simple switch mode power supplies, it's just like a switching transistor. On this, I think it's all done through this rather fancy module here. So basically that's got the power transistors in it which actually do the high speed DC switching. And what we hit that transformer with then basically is not AC like in a conventional linear power supply. We hit that with very high frequency DC pulses, which basically transfire through and you get a lower voltage DC out of this side. So that is an isolation transformer. It's just working at a very, very, very high frequency. So basically then that comes onto the low voltage side of the power supply, and this is where I think we've had most of the issues. I think all the issues on this side will be through the electrolyte leakage which has got over here. Like I say, it really did cover the entire board. So essentially what we've got on here, we've got various diode bridges, various power transistors and things like that to take what voltage this gives out and actually step it down to the 5 volts we need, the 12 volts we need, the, you know, the minus voltages that we need. This being a fairly more sophisticated switch mode than like super basic. We also have feedback, basically all this here, which is we've got various ICs. Basically we've got like a feedback control here, so that can tell probably this here, hey, we need more voltage, you know, we've got more load, step up power basically. So this side is communicating with this side of the power supply, but they're not directly connected. This is where this is safe, this is isolated. That's an isolation transformer, and basically all the torque, all the feedback between this side of the power supply and this side of the power supply is done by, I don't know if you can see them down there, but we've got two little what look like chips there. Those are what are called opto-isolators. So basically you've got like a photo transistor on one side and a photodiode on the other side, and it's using light pulses to basically take the data, what this is saying, and send it across to this side of the power supply. So that in essence is like a really simplified way of explaining how a switch mode power supply works. That's from someone, like I said, that is not an expert on switch mode power supplies, and really, if they can avoid it, prefers not to work on them. That being said, like I said, we are going to work on this one. We are going to see if we can get this to actually work again. What I'm going to do, I've got the old phone here, and I'm going to start taking photographs basically of everything around here, resistor wise, capacitor wise, I think I'm going to end up taking all this wiring off. This is one of the things. So I want to see exactly where every wire connects to the board. So I don't get, you know, a voltage rail down in the wrong place. I think that's good enough. We'll do some over here as well. Can't take too many photographs because now in the digital age, it's no problem. If you don't need them, you just delete them after you've finished the job, don't you? Probably won't resort to taking all these little passes off, but it's good reference. I think that should do. Right, let's get to it. This is going to be quite a daunting task, actually. We'll see what we can do about removing. Let me get you down a little bit. Yeah. Let's see what we can do about removing all the solder around here. So basically we can get all the wiring off, because there is loads of electrolyte around there we're going to have to clean off. This is a fairly major task, repairing this power supply. The easier route would literally be to snip these wires off, find a power supply that's compatible, and like I said, rig it into this case. But if at all possible, like I said, I would really like to see if I can save this power supply. That's not going to work. Right, I'll try and get the ones I can get off with the desoldering station. Oh, I can smell the electrolyte already. So this has to be done. We need to get this off. Actually, both those are exactly the same, so we can get them out. That one's out. That's holding in still. Let's get some. Let's give that another suck. Right, see if we can get that out this time. There we go. So basically it's going to be a case of going round like this, getting all this out. I might take another picture of that. Now we can see properly down. You can't see because I'm off shot. Now we can see properly down in there. I don't want to get to the point where we get all this fixed and then I don't know where all the wires go back. So we'll get the old phone in there. We'll get a good picture of that. Right, perfect. We'll try and get them out of there. Oof. Right. We'll tack those there. Well, apologies there, battery failure. All you've missed is me take those off there. So basically we've got all the smaller wires off, and at least we can see quite easily now where they go there. So basically we've got to deal with these. I think what I'm going to try actually is basically getting hold. So we'll start with the white, which is the end one there. I'm going to hold it from that side, and we're just going to try heating it up. There we go, lovely, that comes straight out. So that's that one. Let's try blues next. That's another nice thin one. And again, we'll just I'm holding it from the back. We'll try heating the solder up. That's come out easily. So that's them three out. Hopefully we can do the same with these. Let's start with that black there, which I think is that one there. There's a lot of ground plane here. It is coming out though. There we go, that's the first one out. There's a lot of ground plane here, so it's taking quite a bit of heat to actually remove them. The wire is just a little bit too thick for the desoldering station, so I'd have to swap out to a different tip. There we go. Because we can pull one wire out each time individually like that, it's actually quite easy to do this. The only problem is that this absolutely stinks. There we go. But I don't think you need to see me do all this, so I'll bring you back when I've got all this cleared off here, and we can actually look and see quite how bad the electrolyte damage is. So back in a sec. Right, okay, well, we've got all that off now. I've had a bit of a clean up on that side and basically made that side there as good as I can. Round there where I took them capacitors off as well. You can see the difference between there and over here where I've not done as much cleaning. You can see it's pretty filthy here. We'll give that a quick spray down and a spritz, see what it comes up like. See, most of that does actually come off fairly easily like that. The trouble is I can't get in properly with all these components around here. So even as much of an absolute pain in the backside, look, can you see that there straight off? That's still the electrolyte all over this part of the board. Right, let's give it a quick clean like that. Let's go in for a quick smell test. Just clean my iron off. It's a lot better, but I can still smell it. So really I've got no choice. I'm going to have to take some of these bigger capacitors off so I can get down there. I'm going to take that off. I'm going to take these resistors out. I'm probably going to go as far as pulling basically all these components off. Everything that I don't really want to get wet, and then I'm thinking I'm probably going to stick this thing in the sink and give it a damn good scrubbing that way. I think it's the only way I'm going to be able to get all this electrolyte off. So we may as well start where we mean to go on. I've got a tray here, so basically everything that I pull off can go in that tray. Let's see how hard it's going to be to take this main transformer off. You can already hear a lot of hissing from the electrolyte that's got into the... That one was alright. The electrolyte that's basically got in under and into the solder. So we've got to do this work if we want a good reliable repair. And we could do all this work and find out I can't fix the the switch mode power supply because as I've already mentioned, I'm not an expert with them. Let's see how hard this is going to be to get off anyway. To the high voltage side, there's actually less mass on the planes we're desoldering from, so they came off quite easily. It's not going to be the same matter, unfortunately, on the low voltage side. That won't come off. Anyway, I don't need to bore you with me doing this. I'll come back when I've got basically these desoldered and we can have a look at the board proper just before it goes into the sink. So back in a sec. Right, okay, we're back, and yeah, pretty dramatic, I know. Basically, I've stripped everything that I don't want to get wet off this board, and this is the reason. If you look here, this is where the heatsink with all them diodes and power transistors and things are. If you look underneath it, basically this is all bad, you know, leaked electrolyte that was underneath there. Same with that switching transformer there. If you look underneath, it's absolutely filthy. Even that switching control module there, if you look underneath there where the heatsink is, just look, that's absolutely covered in that capacitor spew as well. All on the board where I took that off. Again, look, it's all still full of that capacitor spew. All over this part of the board here, them opto-isolators, all that's covered in it. So really I had no other choice but to completely strip this down. We'll give this a bit of a spray with some PCB cleaner here now, just to see if we can loosen off the worst of it. I've taken a lot of the electrolytic capacitors that were in this area off as well. One, I want to check them, I want to see that they're okay, and two, it just made it easier to clean round. See, this is having some effect. We are at least dislodging some of this disgusting capacitoric. I want to be trying to be careful not to nudge that and adjust that. These ones I'm not minded about. Those are adjustments for all the output voltages, but that's a bit more critical. Like I said, I don't want to try and mess with that really. I think that adjusts the overall voltage to the switching transformer, or the frequency or something like that. Right, what I'm going to do, I won't do it on camera because I have to tidy the kitchen up if I did. I'm going to take this into the kitchen sink and I'm going to give this a really good scrub now with some soap and water and a very soft brush. Get all that off it, same on the other side, and then I'm going to probably bang this in the oven actually for 15-20 minutes, just completely dry it out. Then we'll come back, then we'll start looking at putting all this back together and see where we can actually get with this. So back in a sec. Right, okay, we're back, and as you can see, actually the board's looking quite a lot better. That was a good scrubbing in the sink with some dishwashing soap and a paintbrush and a really good scrub round. Then it's been on the radiator for 40 minutes, and then after that I actually went over it with my hot air station and went over all the ICs, made sure everything is completely dry on there. If we have a look on the other side, like I said, that's now looking as good as I can get it anyway. I wouldn't say it's good as it was in the factory, but it's not far off. There's very, very little corrosion damage on it. What there is, I'm not really worried about. Again, on this side I managed to get most of the electrolyte damage off, cleaned up. Like I said, it's come up really quite good. I'm quite pleased with that. In the meantime, I've actually been through the rest of the components we've got here. Well, what I can do anyway. So I've tested all the capacitors that I've taken out, and actually they're all absolutely fine. I've still got to test these resistors and just make sure. I mean, I don't imagine there's anything wrong with these resistors, but I will test them before I put them back in circuit, just to be on the absolute safe side. I've also been round and I've tested every diode that I can spot on the board, just on the board, just with the diode test on my multimeter here. I just confirmed that none of them are short, none of them are open circuit. So I'm basically just doing simple checks that I can do, that just to make sure everything's reasonably happy. I've still got to do a continuity check on that isolation transformer there. I've got to just check that choke there that we took out. I've tested on here. Most of these are just diode blocks. I've tested all of them and none of them are short. They all test as good as they should do. The only thing on there actually I have not tested yet is that there, which I believe is a transistor, the way it's mounted on here. So I might just pull that off the board and we can throw it in there and just double check that. Actually, all I'm doing at this point is just trying to eliminate anything that could possibly have blown, because be aware that someone had tried powering this up before I got it, because obviously I bought it as they tried it and they couldn't get any power out of it. So let's put that in the tester. Is that going to go in there? Are you going to hold in there? Okay, and let's see what this says that is. Right, diode. Alright, hang on a minute. Perhaps that wasn't making good contact. Let's try that again. Let's go in like that. I think we're getting a good contact there. Oh, no. I do have to do... This is not going to... there we go. That's better. There we go, and it's testing as a PNP transistor. Excellent. Let's just try that again. Yeah, there we go. Now I've got good contact with it. It's testing as a PNP transistor, so that's fine. That can go. In fact, let's clear that off there. I wasn't going to redo the thermal grease because it's actually quite good. It's quite nice and gooey, but seeing we've taken that off, let's clean the old thermal grease off and then we'll apply a little bit of new. I'm not going to do it to any of the other ones that we've not taken off, which I've tested actually on the heatsink, because like I say, it's still nice and gooey. There's nothing wrong with it. Where's my thermal grease gone? I know I've got some. Don't make me use the good stuff that I keep for computers. Oh no, no, that's sealant. That won't do. There we go. That's what I want. Thermal grease. So we'll put just a little bit on like that. Get that drawer to shut. I hate drawers that aren't shut properly. There we go. And we can get that re-mounted on there like that. And really we are at the point now where I can start putting all this back together. There we go. Wipe the excess off. Yuck. Hate thermal grease, it goes everywhere. There we go, that's not too bad. Right. Let's try, in fact let's get that as the first thing back on the board, because that's all tested. I'm happy that everything in there should work okay. And the only one that's going to be a pain is that I've just taken off, because it's not going to line up with the holes. Right, let me slacken that screw off. There we go. And then we'll get it in the holes. And then we'll tighten the screw up. Right, hang on. Right, we're in. We're in. So that's back on the board. Let's get the screws in the bottom of it to hold it down. Which ones are they? Because there's two different types of screw. Ah, it's them ones. Because these stand off slightly. The other one screws straight to the board with that big control chip. That is still my biggest worry with this power supply. If there's something wrong with that control chip, I don't think I'm going to be able to get a replacement for that. Come on, go in the hole. Oh, I'm going in the wrong hole. It's that hole. There we go. Right, so we're screwed down there. All them are through in nice. That's all back in place. There's a little thermal sensor there. It's just pushed up against the heatsink and that's gone back in place. We'll nip that screw up that we slackened off to get that back in. Alright, that's good. Let's solder them components back in place and then we can move on. Right. So, clean my iron off. Let's see how easy these are going to be to solder back in now. Hopefully we've got rid of all that horrible that's still not soldering very well. I think we're going to use flux as well. And this is after I've cleaned everything. I've cleaned all the pins. This is the problem with that when you get electrolyte damage. But where are my stronger glasses? It'll make my life a bit easier if I put my stronger glasses on. Right, let's swap them out. Well, that's better. There we go, that's taken. So we're going to have to do another load of cleaning up of flux after we've done all this rework. Because I think we're going to need to use a lot of flux to get this to solder properly. There we go, that took that time. Not so bad, but it's all down to that how bad that electrolyte leakage was. It's one of the worst I've actually dealt with this. You don't usually have to go to quite the lengths I've had to go to on this board to sort a little bit of leaky electrolyte out, but on this, like I say, on this instance, this one was really, really bad. Just going in these to reflow them and make them a bit neater. But at least I know I've got a good connection there. A decent flowed solder there. That's a little bit too much on that pin, but No, I'm reasonably happy with that now. Those are all changed. So that is that module now put back on. I suppose we should look at putting the main transformer there back on. In fact, I'm just going to do a little bit more cleaning on the bottom of that because there's still residue from the capacitor leakage on there. But yeah. See that there? There we go, that's better. Just make it as good as we can before we reassemble it, so we don't want to be going back in and having to fix damage caused by corrosion because we haven't got this off the board and we've got the computer working again and it's getting warm and the spew starts doing its damage again. Right, there we go. Quite happy with that now. Let's get this transformer remounted. It goes straight back on like that, lovely. One thing to remember is don't put something big on like this and block where you try to put another component on, or else you're going to be cursing yourself and taking them back off again. Right, now let's see if we can get a little bit more heat in the iron actually for this. Some more solder. I'm seriously running out of solder. I'm going to have to order some. That's better. That little bit of extra heat in the iron is really, really helping there. There we go. Plenty of solder on these because they are going to be holding quite a high current, so you want them right. Right, that's looking pretty good. Let's right. Is it going to affect us putting anything else back on if we decide we're going to put that module on next? I don't think it will. Right, we took a component off there, didn't we? So just clean that hole out while I'm here, because I just noticed one of the holes we need to use is blocked up there. There we go. Right, let's put that this big module back on now. This actually wasn't quite as bad as I first thought it was. The bottom of it was absolutely covered in capacitor juice, but it's not actually got onto any of these legs. They're all still nice and shiny. I've not had to do any redressing on them, unlike the legs on those, which are absolutely covered in capacitor juice and are gone all corroded. There we go, that went straight back on the board, lovely. So, oops, no, oh you little bugger, it's come back off. Not so lovely. Let's try that again. So I want to try and get it on the board and then I'll screw it in place before we solder it in place. So hold it this time. Let's get it out screwed down. There we go. And I'll get this soldered back in place. There we go. So it's starting to look a little bit more like a power supply again. We've got a resistor there we need to put back in, which, if I remember correctly, is that one there. We'll just give it a quick test before we put it back in. Basically, I'm testing everything that I removed before I put it back into the board. I can't guarantee we've tested absolutely everything on the board this way, but we're doing a fairly good test as best we can. I don't know why it's telling us there's 2 resistors there. Just try putting that back in a different way. Let's go between 3 and 1. Right, it's telling us we've got a 14.4 meg ohm. That's looking really weird. Why is it doing that? Let me take everything out. Let's just test it there. Right, it's telling us we've got a resistor when we've not got anything in the tester. I think my tester's gone on the fritz. Let me try unplugging it and let's see. See what it's telling us now. Yeah, there's something's gone wrong with this tester, obviously. Let me get Old Faithful out. There he is. This is a bit iffy in some ways, but you should still be able to test this resistor. There we go. 1.285 k ohm. That should be right. In fact, let's try that. It says it's 0.22 k ohms. So that's what, 22 ohms. Let's try it on a good old-fashioned. Right, let's see what that says. Yeah, 0.22. It's a very, very low value. But it's not short and it's not open circuit, so I can assume that's fine. It's just a very, very low low value, high wattage resistor, and that came from there. Put that back in. Perhaps it went in that way. There we go. So let's solder that back in. And really, this is all I can do at the moment. It is just a case of going through all the components that I removed, testing them, and putting them back in the board. There we go. That's back in. That's that resistor back in there. We've got the mains isolation transformer, which is that we just need to quickly test. We'll give the bottom of that a quick clean up because I've just noticed more capacitor goo on the bottom of that. That needs to go back in. The switch needs to go back in. The switch actually, it was a good thing I took it out because give it a shot of switch cleaner, and now it doesn't stick anymore. That's nice and positive click on that switch now. Like I said, that was all gummed up before. A quick shot of switch cleaner while I had it off and work it in and out a little bit, and that's good to go again. Right, now that's what we was doing, was testing that, just make sure that that works still. Put that on continuity. Obviously we've got 2 windings on here. That's 1 winding. That's the other winding. Just make sure we've not got a short between the 2. No, we haven't. Right, so we know that that's good. That can go back in the board. That goes in the board like that. Does it? Which way do you go in? You go in like that, don't you? Oh, so we need to clean some solder off on this side. Where's my solder brakes? Can't be bothered switching the desoldering station back on. I think we can do it with a bit of braid. Oops, there we go, that's that one done. There's a lot of solder on there. Dear me, there is a lot of solder on there. There we go, that's that one done. There we go. Oh, one more. Oops. Ah, come on. We're nearly there. Where's the solder sucker? I should have just fired up the desoldering station again, shouldn't I? There we go. There we go, that's better. Yeah, I think that'll do us. Right, let's get that reinstalled. Then we're in. There's just one there that's been awkward. Let's see if we can get this solder out. There we go. Just heat it up a little bit while it was going through, and it popped right through. Lovely. Let's get that soldered in place. One there. One there. One there. And one there. Right, so that's the isolation transformer put back in. Let's put the main switch back in. That was a bit of a pain to desolder, I've got to say. Right, let's see if we can get that to... I think we're going to have to do a little bit of solder removal around here as well. There we go. Oops. There we go, that's better. Alright, we should easily be able to get this back in now. There's lots and lots of work when you're doing something like this. It's not a quicker and easy task trying to rebuild something like this power supply. Where is that? It is. Right. If it wasn't this bad, there's no way you would have to go to quite this amount of disassembly, but when it's that bad that it's literally swimming in old capacitor juice, you've got to get it off the board. Right, there we go, that's nice and flat, I think. That's our main switch back on. We are starting to look, like I said, much more like a power supply now. What else do we need to test? We need to test that choke, because that choke needs to go back on there. We need to test those two resistors. What are these? 0.05. I think these are like half an ohm. Again, I don't know whether my tester is actually going to be able to test these, but we shall see. Test failed, defective device. Let's try this one. If these are indeed faulty, I think we could resistor 0 ohm. Let's try this one again, see if we can get that to say the same. So they are just incredibly low ohm, high wattage resistors. So yeah, I think they're both fine. They're showing 0 ohm, and I think they're like meant to be like half an ohm or something like that by the look of it. So let's get them back in the board. Right, there we go. That's exactly as they were. I think I'll have to hold them with my finger, tack them, get one side soldered properly, and then move over. Yeah, that's holding for now. Let's try and solder the other side and then move back onto that. There we go. Oh no. There we go. There we go. And then we can solder this side properly. They're both in parallel, actually, looking at the board. There we go. So those are back on. Those are fine. Let's have a look at this choke, which is here. Let's clean the legs off on that because they're full of capacitor goo. Let's just see if we can give them a bit of a clean up before it goes back in. I'm hoping that's going to be okay. There we go. I can try it in this, but like I said, this is doesn't look like it's working properly anymore. It's certainly giving spurious readings when it comes to resistors. But my other tester can't test inductors, and I've given Andy back his proper LCI meter. Right, okay, let's see what this can do with it. It's telling us it's a resistor. I think this is faulty. I don't think that's lasted very long, to be honest. We'll just have to shove it back in the board and hope for the best with that one, unfortunately. So let's put that back in. Okie dokie. There we go. That's back in. So we're getting there now. We're getting fairly close to something that looks reasonably normal. Right, we've got a capacitor there that I took out, and we've got a capacitor there that I took out, which are those two, which I've already tested. I know they're good. So let's put those back in. That is that way around. And that is, which way is that one round? Right, so that's the opposite way. So that goes in that way. That one goes in the opposite way. Because that's positive on that side. Right, okay. And bend those out slightly to hold that in place. The other one's actually holding in place quite nicely on its own. Let's get those soldered back in. There we go. Lovely. Still a slight aroma of capacitor juice then when I put those back in. I'll just snip that off because that's a little bit high. There we go. And that one. Right there, those are back in. Right, now we've got the last two capacitors here. Now that one came from there, and that goes in that way. Yeah, that's right. So there we go, that went through then. Because one of the legs on that is a little bit on the short side. Solder that in, and then we can. The leg is literally just long enough to poke through the board on this one. It's in fact, if I had a better capacity to put in there, I think I would do. I might have a look in my stash actually, see if I've got one that's got slightly longer legs. Right, okay, we're back. Now I've got the wires soldered back on in the right place. I've got the mains lead connected back up there. So we're basically ready to do some first initial tests and checks with this thing. This is dangerous, I will point that out straight away. This isn't something to attempt, like I say, if you don't know what you're doing. We've got mains out on the bench here. In fact, that's another thing. Let's give the bench a good sweep. We don't want any little bits of solder or anything like that on there that could potentially short the bottom of that circuit board out. I'm reasonably happy with that there now. We're going to need a load on the power supply. Most switch mode power supplies won't start up properly unless they've got a load on them. So I've got an old hard drive here. That's why I've connected both of those up. So basically what we can do, we can plug the hard drive in there. I think this hard drive still spins up. We can connect the hard drive there to give the board a load. And we can take my tester. Now where is it? There it is. And put the tester up there. Hopefully you can see that, and we can set that to say 20 volts range there. And we'll connect that up to the 5 volts on that connector there, like that. So we can monitor what we've got there. That's looking fairly good. I've got the lamp limiter here. I'm going to basically first power it up through the lamp limiter. two reasons. One, it gives us a way of being able to switch the board on and off without having to actually touch the board, you know, without having to go in here and press that. So we'll switch that on there. Make sure we've got nothing on the board, on the bench, which can get anywhere near this and short on anything. Can you see that? Hopefully you can see the what that's showing on there. If not, I'll just have to speak it out. I'll plug in to the safety lamp. That's plugged into there. The light bulb is in circuit. So basically, when I flick this switch here, we should get power to the board, and we'll see if we can get any 5 volts, see if we can get any voltage at all out. In fact, there's something else I want to do. Some of these will actually detect that the fan isn't running, or they haven't got the fan attached, so I'm actually going to take the fan off this back here, and we're going to connect the fan up as well. We're going to give it every possible chance we can of working. So we'll take the fan out. Plus that will also give us an indication. I mean, the fan twitches slightly but doesn't start up. We know, you know, we're getting voltage to it, but it's shutting down before it actually initialises anything. And that fan's filthy. I will clean that properly after, but it rotates. I think the fan was probably okay. We'll connect that up. There we go. So that's the fan connected there. So that will give us a visual indication as well that something's working. We're connected up to the 5 volts showing on there. We've got a load with the hard drive on there. The power switch is on. So the lamp's in circuit. All I've got to do is flick this switch now and we'll get power to it. We'll see if we get a flash and a bang. We'll see if anything actually works. We have to bear in mind that them two capacitors are wrong. They should be 6800, 6800 UF, and I've got 4700 in there because that's what I had. But fingers crossed that we get some form of life out of this power supply. So 3, 2, 1. I'll switch straight off. So the lamp lit and then went out, which is that indicates basically that the capacitor there was charging. We are going to have to be super careful around this at the moment because there's a chance we've got quite a charge on that capacitor. Apart from that, we got absolutely nothing. We got no flick from the fan there. We got no sign of any voltage up there. That's not looking particularly good. Let me just see what voltage we've got on there. Hopefully those are nice big bleed resistors and that's bled off, but let's disconnect that from there. We are switched off there. Let's go right up onto the 500 volts range. I will very carefully turn this board over and we'll just see if we've got anything on that capacitor before we go any further. And that's bled away to nothing. So we've got a good bleed resistor. Hang on, we've got 100 and there's still some voltage there. Yeah, we've got about 130 volts on that. It's slowly bleeding off, but I expect that to bleed off a little bit quicker than that, to be totally honest. And just be a little bit careful around the board. So what have we got going on? This is what I was worried about. So it could be that there is faulty. That is basically the brains of the switching for the power supply. and if that's not working, because our fuse was good. If our fuse was bad, we wouldn't have got the lamps lighting up like that for the surges that capacitor charged up. But it's not doing anything else. It says that capacitor's charging, so we're obviously getting the 400 or so volts DC coming on it, but it's not going any further. There's a couple of transistors, small transistors down there that we could possibly check. There was a chip there which is obviously part of the control logic. We could have a look at that, see what the pinout for that is. We might be looking at seeing whether we can put a different board in that case though. Like I said, my knowledge of switch mode power supplies is not brilliant. I'm not an expert with them or anything. I could check certain things, I know certain things. I'm pretty certain that that side of it actually is not too bad, the low voltage side. Like I said, we've certainly checked all these parts that are potentials to short, and they're all absolutely fine. We haven't really checked the switching transformer there. That could indeed be faulty. We could have a bad winding on there. I'm not 100% sure how it's actually connected up though to check that. But like I said, we could also have a fault there. Let me go away and have a think about this, and I'll come back when I've decided possibly what we can do, how far we can take it from here. So back in a sec. Right, okay, we actually have a tiny bit of progress. I went back over the board underneath, and I actually found when I resoldered that module there, I'd missed one of the pins. And it was rather important pin, because it's the pin that actually connects between that, the switching transformer, and that control module there. So anyway, I've redone some of the soldering I'd done on the bottom and tidied it up a little bit. We're not there yet, but if I power it up now, bear in mind I've still got it running through the lamp, the safety lamp. I actually have swapped to a different hard drive, so I wasn't 100% sure the other one was actually spinning up and giving a proper load, but I've confirmed that one definitely spins up on another power supply. If I switch on now, see we got some activity there, and we actually saw, I'll switch off straight away, but we actually saw a bit of voltage gain on there. Now that should be the 5-volt line, and we got nowhere near where we should be, but we actually did get voltage produced, and as you actually saw, the fan did spin for a second, but it seems to be going into some kind of shutdown or protection mode pretty much straight away. But I think it shows that basically this side of the power supply may actually be okay, it may actually be working, but for some reason it's, you know, it's detecting an overload or something, and this is actually shutting down. Let's see if I swap over onto the other line on here, and let's see if we've got anything different there. So again, I'll switch on, and we just get a little bit of like I say, a voltage spike just for a second, and then it decides no, there's something wrong, and it shuts down. We'll try that again. We nearly got a whole 4 volts then for a second, but that should be the 12-volt line on the 5-volt line there. Oh, we got 5 volts for a split second then. Let's try that again. No. You have to kind of like give it a second for, I presume, for a capacitor to discharge or something like that before it'll actually try it again. There we go, we've got like 3.5 volts for a second there. So we're not there yet, but we are a little bit further on than we were. I have tried to track down some of the parts. Those are available. The cheapest I can get one is about £20 delivered though. So, you know, is it worth it? I believe that little IC down there, which is like kind of a companion IC to it, I've also got the data sheet for that. I think those are available. The trouble I've found is I've managed to get the data sheets for these ICs here. That one there, I've got the data sheet for it, but unfortunately it's in Japanese. I cannot find a data sheet for it in English. I mean, there's some of the new, you know, some of the numbers and what have you. I can basically make out what it does and how it should connect, and the fact that that chip there is like a companion chip. It's like a voltage comparator that it uses to send feedback to that. Fortunately, this seems to be very much the stock circuit which I found in the data sheet for that there. It looks very, very, looking at what components we've got down there and what have you, it's basically, I think they've basically used the stock example from the data sheet for most, I beg your pardon, for most of this. What it didn't have though is that feedback that this has through the opto-isolators from this part of the circuit. So I think this is where I'm going to have to look next as well. It could be a case of, with all that corrosion stuff, let's check these ICs over here, make sure they're getting the correct voltages and things like that. Because it could be as simple as one of these is malfunctioning and telling the power supply to shut down when actually it's the chip that's at fault, not, you know, something in the power supply which is overloading and causing it to shut down. So I'll do a little bit more research, see what else I can find out, and we'll take it from there. So back in. Right, well, we're back, and I still haven't made really much progress here. I've been basically getting data sheets for some of these ICs here, pinouts for them, tried to check some voltages, but the problem is that you find the voltage on there, seeing they're getting a supply voltage, and it collapses before you can really ascertain what's going on. I don't think there's anything wrong with those ICs. I think it's somewhere else. I've got this horrible feeling I'm going to literally have to go through component by component checking, basically working this way. I'm pretty convinced the fault is somewhere on this side now of the power supply. I think the actual main power supply here is basically working, but this is telling it I've got a fault, shut down. Because it's fairly consistent. Like I say, I power it up, we get nearly the voltage we should get. So it is producing voltage. You can go on the 5 volt side here, do the same. So we get a little bit of activity from the fan, and that's it. It goes down. It shuts back down. There we go. And that is all I can get. All I can think of, like I said, I am not an expert with switch mode power supplies. I hate the things, to be honest, working on them. And these are the simpler ones. Like I said, the more complicated switch mode power supplies, you haven't got a hope in hell. I suppose all I can really do is start pulling some of like these transistors that I haven't tested already, test them, perhaps test them up to isolators, and just try and figure out what it is. I'm fairly certain I'm fairly close to actually sussing this, to be honest. We've certainly got more activity than we had when we started with this thing, because we are actually getting some output from it now, which we weren't getting when we started. Anyway, I'm going to leave it there for now, because I'm pretty sure this video is already massively long. I was hoping to get a working power supply by the end of this video, and I don't think we're going to get there. So I will carry on plugging away with this off camera. If I can't get anywhere, then we're going to look at seeing what we can substitute this thing for, and like I said, build something else into that case that gives all the correct voltages out. But I will carry on seeing what I can do with this. If anyone's got any suggestions which knows more about switch mode power supplies than I do, suggests anything that I can check and try, please put it down in the comments. Anyway, like I said, I'm going to leave it there for now. I hope you enjoyed watching me struggle with this damn thing, so I will say thanks for watching and goodbye.